I'm good, thank you. Welcome back, everybody. This is section 6.1. Areas between curves. This is the last section. Woo! Oh, last section. So what does that mean in terms of pacing? Well, tomorrow will be a work day over section 6.1. I should be able to get this done with the time remaining in class today. It's not a very difficult or lengthy section, so it should be pretty good. Tomorrow will be a work day, or if I need to finish up like one more slide or one more example, it should be too bad. Then Wednesday of this week, I will give you your test review. Thursday of this week, we will go over it. And then Friday, one-day test. Just one day, because it's only two sections. The test over sections 5.5 and 6.1. So the quiz that you just got back, and then just one or two problems from section 6.1. Does that sound good? Test on Friday. Then next Monday, a week from today, I will give you your exam review, and you'll have, I'm going to give you guys at least 2 days to work on it, because it'll be kind of a lengthy exam review. Basically, I'm just going to compile everything that we've had from the test and give it to you. So, because again, it's a full year. Sorry about that, unfortunately. So we've got next Monday and Tuesday, exam review work days. Wednesday, Thursday, we'll start to go over it. And then is Friday the picnic? Next Friday?
Yes, my birthday.
Friday, so I won't see you all on that Friday. That's your birthday?
That is.
You said it like 9
Every
times.
single time we don't know.
You said
May 7th. Mark the calendar.
So next Friday I won't see you, and then we'll have one more day to review for the exam on that next Monday, and then we'll take our exam on Tuesday and Wednesday. And then again, I think I just need to bring you into class on that Friday. I do want to give you that survey, make sure, see what we got there, and yeah.
So not tomorrow, but a week from tomorrow, we're doing exam review.
Yeah.
Is that on the short schedule still?
Yes, tomorrow we will.
Ooh, that's good.
Not for, there will be an adjusted schedule next Tuesday, Wednesday, because that's the science test, but it doesn't impact this class anyway, so.
We have it tomorrow.
Right, tomorrow and Wednesday is it's all the math test, so, say an extra little prayer for my Algebra 1 students.
We'll be all right.
Will they? Will they? Will they? Will they? All right. So section 6.1. Now, there's a lot of application of integrals that you can get into. A lot of really cool application of integrals that you can get into. But that's kind of reserved a little bit more for Calc 2, Calc 3 if you go into that. So if you have to take additional calculus courses beyond this one, you get into some cool application of what does it mean, because we're finding areas. You can use that as application to find certain areas, certain things. And then you can get into like double integrals, which is like volume. It's pretty cool. But one of the applications that we could talk about is areas between curves. Areas between curves. Now, area we know is an integral, right? If I can perform an integral over a definite length, that is an area underneath a curve, right? So if I take, I'll draw it up on the board here. If I take some function, let me move it down a little bit more. If I take some function here over the domain from A to B, and it says, okay, I've got I know that the integral, the definite integral from A to B of that function is, not a text pen, come on, highlighter, is all of the stuff from A to B within there, right? That's like the past, I don't know, several weeks that we've been doing, right? That's what we know. But what we're going to say here is, well, what if we have another function? What if we have some other function from A to B? Doesn't have to look exactly the same, could behave quite differently. From that same length from A to B, what if I only want the area in between those two functions? Well, what I can do here is I can take the area from A to B of the red function. Think about what I have here. All I'm going to do is take away the area from A to B of that red function to get the total area in between. Like if I just erase this piece, and what am I truly erasing here? I'm erasing the whoa, I just erased the line. Whoops. What am I truly erasing here? I'm erasing away the integral of a to b of the red, right? And if I'm erasing away, all I'm doing is subtracting that away. So in essence, if I want to find the area, the shaded region right here, what I can do is I can take the integral of the blue and subtract away the integral of the red. I can take the integral of the blue function and subtract away the integral of the red function. Okay, and that's I can demonstrate this in the rectangles as well, right? I can find those rectangles, but all I'm really asking you to do is just take the upper function and subtract away the lower function. And here's the Riemann sum for that. But honestly, we don't need to even worry about the Riemann sum because what we have here, we can use integral notation. If I want to find the area between two curves, you take the integral of f of x minus g of x along a to b. That's really all you need to do. Understand that this is equivalent to saying the integral from a to b of f of x dx minus the integral from a to b of g of x dx. Whatever is easier to perform, you can kind of change it up. You can find the integral of the entire thing, or you can find the integral of the difference. Right? You can take the integrals as an entire difference or separate it. Break it apart piece by piece. Find the integral of one piece, and then find the integral of the other piece, and then subtract them. And that's going to get you. Now, how do you figure out what's f of x and what's g of x? Well, you just have to logically, graphically reason it through. What's on top, what's on bottom? What is the function, which function is lower than the other function? Because the function that's on the top is going to be your f of x. The function on the bottom is going to be your g of x, graphically speaking. Yeah, whatever's the smaller one. Honestly, though, if you didn't want to do that, if you didn't want to bother with what's the bigger one, what's the smaller one, in essence, all you would need to do, I'm going to put it in blue, is just take the absolute value of that. If you messed up the order and you said, oh, I'm accidentally taking the one that's on the bottom rather than the one that's on the top, all you would be getting is just the negative of that area. So if you want to think about it this way, you could always just say, well, if I didn't want to think about what was on the top or what was on the bottom, just take the absolute value and you'll get the total area in between the two. And that's it, okay? So let's practice with it. Let's see. Find the area of the region bounded above by y equals e to the x, bounded below by y equals x, and bounded on the sides by x equals 0 and x equals 1. What I'd like us to do here is graph it out, because that's what it's going to ask you to do on a lot of the homework problems. On just about every homework problem, it's going to ask you to sketch the graph. Now, you can use your calculators to assist in that sketch. You can use Desmos to assist in that sketch. But you will have to sketch it out for each one. So let's do that. Here, I've got y equals e to the x. Now, I'm going from an interval from 0 to 1. So if I've got e to the 0, what is e to the 0? 1, right? So here, 1, 2, 3. So e to the 0 is 1. What's e to the first? E, right? So 2.71828. So just a little bit under 3. Somewhere in there. And it curves up because it is an exponential. Now, if I've got y equals x, where's y equals x at when x equals 0? It's at the origin. 0, 0. And where is it at when x equals 1? 1. So what am I looking for? I'm looking for the area that I've shaded in purple right here. That's what I'm looking for. What is that equivalent to? That is equivalent to, I didn't use any of this stuff over here. So that is equivalent to the integral. What's my left-hand side? 0. What's my right-hand side? 1 of top minus bottom. E to the x minus x. And I always forget my dx. Do we know how to evaluate that? Yeah, we've been doing that a million times. So that means if I want to do the integral, it's, well, integral of e to the x is e to the x, and then it's minus x squared over 2 from 0 to 1. Excuse me. Which is essentially just e to the x, or e to the 1, minus 1 squared is 1, 1/2, minus e to the 0, which, what is e to the 0? 1 minus 0. Okay, so e minus 1.5, negative 1/2 minus 1. E minus 1.5, which I bet that's the answer to the book there. Yeah, e minus 1.5. I'll put it as a decimal here. E minus 1.5, enter, 1.218. And essentially, that's the whole meat and potatoes of today's lesson. So let's try another one, shall we? Find the region enclosed by the parabolas y is equal to x squared and 2x minus x squared. So notice this one, it doesn't give you an upper and a lower boundary. It doesn't give you at x equals 0 and x equals 1. So what you have to figure out is, where is the area enclosed? Find the area of the region that is enclosed by the parabolas y is equal to x squared and y is equal to 2x minus x squared. Okay, so let's graph. You know what, let me graph it in here. 2x minus x squared. Okay. I don't have to go into the negatives here, so I'm just going to put my graph up here. Let's graph y equals x squared. All right, well, that's 0, 0, 1, 1, 2, 4. I know it's going to go on the other side too, but not really too worried about that side. You'll see why. Okay, now let's graph. Y is equal to, okay, negative x squared plus 2x. I just like it in the standard form. The negative out front means it's going to open downward. Where are the zeros of this thing? Well, the zeros of this thing, if I pull out a negative x, that's going to give me an x minus 2. So x equals 0, x equals 2. So it's going to cross here and then here. And I know it's shaped downward. But you know what another very important piece of information is going to be? Where do these things intersect? I know this is going to generally be shaped like this, but where do these things cross? Let's take a look at that. How do I figure that out? Well, you just set them equal to one another. Y equals x squared and negative x squared plus 2x. All right, let's add over the x squared. That's 2x squared minus 2x equals 0. So pull out a 2x, leaving an x minus 1. So it crosses at x equals 0 and x equals 1, which makes sense because you see it crossing at 0, 0. So now, and it's going to cross at 1, at 1, comma 1. That must be that high point too. Sorry, smooth curve, smooth curve. So what region is enclosed? just this teeny tiny little piece right here. Better with sound effects. That's all I'm looking for. Okay, so how do we write that as an integral? Well, what are the x values that are going to be our boundary lines here? 0 to 1, the intersections. Especially if you're looking at area enclosed by two certain things, you're looking for the intersections. Going from 0 to 1, and now I've got to take red minus blue. I've got to take red minus blue. Okay, negative x squared plus 2x minus x squared dx. Simplify a little bit. Okay, that's 0 to 1 of negative 2x squared plus 2x dx. And now we perform the integral. Negative, oops, no more integral sign. I don't know why that's the sound effect of the day. Plus 2x squared over 2 from 0 to 1. Which cancels there. That's a negative 2/3 x to the third plus x squared from 0 to 1. And the nice thing is if the polynomial I got 0 on the bottom, all I got to do is plug in 1. So it's going to be negative 2/3 times 1 to the third, or negative 2/3 plus 1 minus 0. Because if I plug in 0, I get 0 for both parts. So negative 2/3 plus 1 is 1/3. So that's the area in between those pieces. Okay. Now, I'm going to skip this problem just because it gets a little lengthy and I don't want to do it. But the reason it gets lengthy is because you have to do U substitution. Like, think about if you wanted to take the integral of this. X over x squared plus 1. Oh, square root of x squared plus 1. Right? What would your U be? X squared plus 1. See, we know how to do this. It just might get a little bit more involved. The more involved taking the integral is, the more lengthy the problem might be. Right? Okay. I do want to look at this one, though. Because this is where it starts to get a little funky. Okay, what I'm going to do is I'm going to use my graphing calculator to assist me in graphing this problem. So I've got y equals sine of x and then cosine of x. I mean, I know what these look like, but this is just going to help us. And I'm going to change my window. And instead of going from negative 10 to positive 10, I'm going to go from, I'm going from 0 to pi over 2. So let's make the minimum, let's just go negative 1, give me some a little bit on the left side. My x maximum, instead of pi over 2, let's just go pi. Okay. And then my y minimum and y maximum, let's go negative 1 to positive 1. So let's go negative 2 to positive 2. Yep. Yeah, I really am really sorry about that. Okay. So what am I really looking for here? Well, what the what? I'm really looking for, now where is pi over 2? Pi over 2, here's 3.14 divided by 2, 3.14 divided by 2. 1.57, so 1.57. So it looks like we're right over here, which makes sense. That's where it's going to cross, right? So if I want the area bounded by the curves, I want this and this. Okay. I want those two pieces together. So what am I going to do? I'm actually going to treat it as two separate integrals. Okay, I'm going to treat it as two separate integrals. I'm going to do an integral from 0 to where? Where do they cross? I want to know when this is true. When is sine equal to cosine? When are the two coordinates of the unit circle equal to one another? Radical 2 over 2. Okay. What is that? Is that the 45 family? That's pi over 4 family? They're crossing at pi over 4. So pi over 4. From 0 to pi over 4, what's on top? Sine or cosine? Well, wasn't that? Cosine was on the top, right? The cosine starts up at the 1, right? Yeah. Yeah. So cosine x minus sine x dx. That's going to be our blue region that I've highlighted here. The yellow region, you know what? I'm going to move this over here. I'm going to add these two things together. And this one's going to be from pi over 4 to pi over 2. And now this one, sine is on the top, right? So it's going to be sine x minus cosine x. Now that we've set this all up, now it's just a matter of taking the integrals. Now it's just a matter of plugging and chugging. So let's do that. So we got 0 to pi over 4. That means, the antiderivative of cosine is sine. The antiderivative of negative sine is positive cosine. From 0 to pi over 4. Plus, the antiderivative of positive sine is negative cosine. The antiderivative of negative cosine is negative sine. From pi over 4 to pi over 2. Okay, well, at pi over 4, this is that radical 2 over 2 plus radical 2 over 2. And now, at 0, the sine is going to give me 0. The cosine is going to give me 1, right? 0, comma 1. Over here, this is going to be, if I plug in pi over 2, that's 90, right? That's 90. So that's cosine is 0, negative 0, whatever. And then this is going to be minus 1. Sine of pi over 2 is 1. See it clear? And then minus, and then I have my radical 2, negative radical 2 over 2, minus radical 2 over 2. Okay, now let's just evaluate. So this is 2 radical 2 over 2, which will cancel out just being a radical 2. I can erase that. And this is minus 1. Over here, this is a plus a negative 1. And then distributing in the negative here, actually, I don't need to do that. This is going to be, just give me a negative radical 2, which turns it into a positive radical 2. So all in total, 2 radical 2 minus 2. Why did that 2 turn into a straight line? 2 radical 2 minus 2. So the more in-depth finding the integral, the more in-depth the problem may be. If this crosses mid-interval, right? If it goes one being higher than the other, in the middle of the interval where you're trying to find the integral of, you have to take it as two separate integrals. You have to take it as two separate ones because it's going to switch top to bottom. You can't just take the absolute value, it's going to switch top to bottom. So you got to worry about, okay, where is it crossing? When is one going above the other? Figure out where they're equal to, figure out where the intersection point is, and then you can figure out where, how to take the integrals. Last problem here. All right, find the area enclosed by the line y is equal to x minus 1 and the parabola y squared is equal to 2x plus 6. Now, to help me out with this one, to help me out with the graph of this one, I'm going to use Desmos, but I could logically reason this through as well. For y squared is equal to 2x plus 6, just so we can see where Desmos is getting this. Isn't this y is equal to plus or minus the square root of 2x plus 6? Right? So this is both upper and lower square root. Like, so it's the parabola sitting on its side, basically. It's the upper and lower square root of the 2x plus 6. So when I go to Desmos, take a look at here and see. Oh, Desmos there. Desmos. There we go. We've got y squared. I'm going to type this in. Y squared equals 2x plus 6. 2x plus 6. Let me zoom in a little bit. No pinch to zoom? Okay. Okay. We'll go a little bit more. And then my next function is just y equals x minus 1. Let me screen grab this real quick. Oh, I wanted to send it to that page. Gonna check it too. No. No. So that was more of like Caddyshack. No. You guys know that movie?
Yeah.
Nobody knows Caddyshack?
Yeah.
I love that movie. That's your homework. So find the area enclosed by this. Now, to find the area here, I could integrate with respect to x. But I would have to do a lot of different funky things. I would have to figure out what my far left is. I got to figure out what this is, subtract it away. Got to do top minus bottom here. I'm going to have some negatives. I've got to figure out, okay, where's the boundary line, like here, and figure out what this area is, and then this area related to this area. So I'm going to try to do it in a better way, which might be a little confusing for you guys. What I'm going to do is I'm going to integrate with respect to y. I'm going to integrate with respect to y. And here's how I'm going to do that. I know that x equals, for this equation, x equals y plus 1. Right? I add the 1 over to the other side. I know this equals, if I shift this around, y squared minus 6 is equal to 2x. And so y squared over 2 minus 3 is equal to x. X is equal to y squared over 2 minus 3. Everybody follow me there? I am going to use these two functions and basically do this. Watch me. Oh, no, don't do that. Smartboard magic here. Oh, come on. Rotate, rotate. Where's rotate? Where's rotate? Flip? No, I don't want to flip. I want to rotate.
Don't you,
Can't
it's
you
the
use
green
the
dot. The green dot.
Oh, duh. Okay. Yeah, I'm going to rotate. There. I'm going to find the integral like this. Okay, I'm going to find the integral like that. And actually, I lied. There we go. Because I want to make it go from negative to positive. Okay. Now, what's the y value that's making this happen here? And there's my lower boundary. What's the y value here? There's my upper boundary. What's on top? The parabola looking thing, right? Y squared over 2 minus 3 minus y plus 1 dy. So if it's easier, you can integrate with respect to y. You could basically like flip your axis and see lower boundary to upper boundary, where are the y values that these things are happening at, so you can create your new endpoints based on the y values, not the x values, but the y values that are where they're happening. Okay. And with the time remaining, I'll just try to finish this out. So this is from -2 to 4. Now this is going to be y 1/2 y to the, oh no, not yet. I need to simplify. Y squared over 2 minus 3 minus y minus 1 dy. Just distributing in the negative, which is -2 to 4 of y squared over 2 minus y minus 4 dy. Now let's perform the integral. So this gets me, I'm going to say 1/2 y to the 3rd over 3 minus y squared over 2 minus 4y, from -2 to +4. Just reducing it down a little bit, 1/3 divided by 3, that's 1/6. Or so 1/2 divided by 3 is 1/6. Y to the 3rd minus 1/2 y squared minus 4y, from -2 to +4. All right, so we say top minus bottom, 1/6 times 4 to the 3rd minus 1/2 times 4 squared minus 4 times 4. And then we subtract away 1/6 -2 to the 3rd minus 1/2 -2 squared minus 4 times -2. I'm going to put each part into my calculator here. This is 1/6. 1/6 times 4 to the 3rd minus 0.5 times 16 minus 16. So this whole first part is going to be -13.3. And then I'm going to do everything inside my parentheses to the right. I've got 1/6 times -8. -2 to the 3rd is -8. Minus -0.5. What's a minus? 0.5 times 4 plus 8 on the end. So 4.6. And so that means -13.3 minus 4.6. And that gets me -17, -18. Must be bigger on the bottom than on the top. Okay. So sometimes it's easier to integrate with respect to y. rather than with respect to x. That means all you do is flip, and then figure out where the y values are that you gotta go left to right.
Do you need these back?
Nope, you can keep it.
Oh, cool.
All right. Last video, not really.
And
Last.
for
Oh, maybe not. Oh, come on. Oh, no. Oh, no. I did record it. It's just not letting me stop it.